Well, guys, I clearly was not there yesterday. I'm not going to be here today either, and I just thought I'd take a minute to kind of go through some of the things in your notes, and hopefully it's helpful to you guys in getting ready for your quiz on Thursday. We'll still shoot for that, and see how you guys feel when I get back tomorrow. If there's anything, hopefully I get back tomorrow, we need to go over. But again, just a quick review. This is something, again, hopefully it was clear in your book, but 6.2, we're still looking at the same case we were looking at before with the shoppers, right? The question was, do you agree or disagree with the statement that shopping is time consuming, and I don't know the other part, but so we population parameter was P, and and then from our sample, P hat was 0.66, right? And so we talked in 9.1, we're trying to figure out if P hat is a good approximation for P, okay? And so P hat was the distribution of that told us, is what would this look like if we took a bunch of samples over the course of time from the same population of the same size, and we found out that it should be a normal curve, and that the mean is close to the population proportion, okay? Standard deviation then tells us about the spread, and again, think about when you think of the normal curve, that's like the calculations we did at the beginning of the year, and that's what we're going to get into in this section, is finding the probability under that curve, okay? So some of the rules, we said, obviously this is just kind of a review. We talked about it should be, maybe it's review in the sense we haven't specifically addressed it. So it should be normal when n is large. The mean of the sampling distribution is exactly P, and then the standard deviation, again, this is new, this last one specifically, of the sampling distribution is the square root of P times 1 minus P over n, okay? And two things, again, I think even on your quiz for 9.1, which we'll go over when I get back, number 2, there were some questions regarding that. And again, I don't know that I had phrased it that way. We had talked about that if you did this many times, they should all have around the same center. When we talk about center, we're talking about mean. So anyway, standard deviation, as you can see, a new formula that you'll need to know in calculating. So they'll have some simple questions just asking you for that. Okay. As it says here, that formula only applies at certain points. And so we have to be careful about that, just checking, but most of the situations that they're going to ask about in the book will cover that. But a couple things for us to notice, as we talked about before, as you have a larger sample, your population is going to, your standard deviation should get smaller and smaller, and that's because the value for n is in the denominator. So just something to look out for. And then because of the radical, right, to increase the standard deviation by, or to decrease it by 1/2, you have to increase n by 4. Square root of 4 is 2, right? So so just a trick to look out for. But rule of thumb then, I can go back. How do we know what is a large part and what is not a large part? Is the rule of thumb tells us, okay? Again, to use standard deviation, to use to say it's approximately normal, our population has to be a certain size, and so we're only going to use that formula when the population is at least 10 times as large as the sample. That's something we did mention before, but again, rule of thumb number 1. This is actually its official name, rule of thumb number 1. So they'll mention it in your book on the AP test also. So just kind of interesting. Rule of thumb number 1. Okay, population is at least 10 times as large as the sample. Okay, so quick situation to look at for us. So in this situation, as it says, simple random sample of 1,500. 1,500, yeah. First year college students, and asked whether they applied for admissions to any other colleges besides the one they got into, right? Really relevant for some of you seniors, hopefully getting some of those results back. But so there are 1.7 million first year students. So the rule of thumb, easily satisfied, right? We don't have to even think too hard about that. And Okay, this is a fact. This is something you can look back in history. In fact, 35% of all first-year students applied to colleges besides the one they're attending. And so you're going to be asked questions like this. What is the probability that your sample will give a result within 2 percentage points? And if you guys remember back to our notes somewhere, we actually did a problem very similar to this. But again, this is what we get into second semester, is simply asking these types of questions. What is the probability that your sample will give you results within this? Okay. So again, our mean for this case is 35% here. So this is kind of background information. We have simple random sample, n is 1500, p, parameter of the population, is 0.35. So the distribution of p hat should have a mean of 0.35, and standard deviation, plug it into your formula there, of 0.0123. Okay. So what we're looking for is probably that like that results would be a sample that we would get would fall between that range, so within 2 percentage points. Okay. That's the short way, as you can see at the bottom there, is the short way of writing that. And again, something that we've done before. We've actually calculated that. So what I'm going to do next is show you kind of, again, briefly, this will be the last thing I'll do, kind of how to get there, okay? I kind of always do this, but the longer way and then short way. So this is not necessarily explicitly in your book the way it's talking about this, but if you guys remember, this is how we find z-scores, okay? We're dealing with finding the area under a normal curve, because this curve should be normal, approximately. And so we have this, right? And normally it was x bar minus mu over sigma. Well, same thing here that we're dealing with. But so z-scores, you guys, p and p hat, we're finding the area of the curve. So again, I'm showing you kind of a long way. Your calculator can do this a little shorter. If you guys remember, you're going to use normal CDF, and you type in your minimum, your maximum, and mean and standard deviation. So we're using the standard deviation we just calculated, but just to show you how this works on kind of picture form, we're kind of going through the math. P hat minus p divided by standard deviation for each one. Notice the middle one here is dealing specifically with, that's the question we're asking. Well, what is p hat if the mean was 35, so, or 0.35? So there are two values at the bottom there. And that underlying part, z less than or equal to 1.63, is all the green stuff, okay? And then z less than, or sorry, so kind of backwards the way we have to do this. But what we do is we find out the less than negative 1.63, and then we're going to subtract. So we're going to do kind of the pink area. Let me put that back up here. So we're doing green minus the blue, and then that's going to give us the kind of the greater than and less than value. So we're doing that subtraction. Your calculator, nice. Maybe you don't have to worry about that so much, because you just set the minimum at 0.33, the maximum at 0.37. So kind of nice. That leads us to rule of thumb number 2. Okay, as long as this works, okay, we're going to use the normal approximation. So this is the other thing you have to check. The only way we know to actually use the calculations we just did is if it's a normal curve. Okay, and we've said it should be, but one of the things we want to check for is to make sure, and this is kind of the rule to check for that. So you're going to check n times the population proportion. Most of the time we don't know, so we might have to use p hat. That's okay. And n times 1 minus. Okay. That's just a clarification. It's going to be accurate and not as accurate depending on the situation. Most of the time it's fairly accurate for us to use, and so we do check, again, as long as this kind of rule is satisfied. So rule of thumb number 1, population is 10 times larger than sample, and then rule of thumb number 2. So our goal, you guys, is we want to check for errors, okay? And so you'll have questions like this. Okay, so another example, about 11% of all adult Americans are African American. The proportion of p hat African Americans in a simple random sample should be close to that. Okay, so the questions we're dealing with again is if a national sample contains only 9.2 African Americans, that's what AA stands for. Okay, should we suspect that the sampling procedure is somehow underrepresenting African Americans? Fair question, right? So what we're asking is, Okay, first off, can we do this? Yes. Okay, it should be accurate. All right, and then mean standard deviation, sorry, found as before, square root of p times 1 minus p over n. Okay, and we get those values, and we're going to do the normal curve. I know it's quick side note, I'm going to put all these notes on RenWeb without the audio, but you can go back and look at some if you didn't get it all written down. But so we're, again, calculating just as we did before, but it's only one-sided. What if we got 9.2 or less %? Okay, and these are our results. So this is what's important. This is what we're doing, again, second semester is telling us that only 1.29% of our samples would have so few African Americans. Okay, 1%, very little of the time, a sample would only have 9.2% of the population if the mean was 11. And so, because it's unlikely, we're probably making some conclusion to the effect of sampling procedure underrepresents African Americans. We don't necessarily know why. We're just saying it does. Okay, so you're finding probabilities just like you did before. Okay, and again, but we're making conclusions based off of that. And hopefully you understand that. Again, think of our penny situation I always go back to, right? If we flipped a coin 10 times and we got only heads, maybe we would want to do more samples, but that comes up very few amount of times. Even more so, let's say we took a larger sample, like 100 flips of the coin, if we got all heads. We're thinking like, okay, this is weird. And that's what this is saying, okay? Hey, here's the sample. If the mean is supposed to be 11% and we're getting 2.9, well, that only happens 1% of the time. And so this is very unlikely. Something must be going on here. So again, there's your homework, guys. And quiz we're shooting for Thursday. If you guys have some questions, maybe when I get back, it might be pushed to Friday, but we'll see. And if you guys have questions, please shoot me an email. Try to answer them in the meantime, and we'll talk to you soon. All right, bye.